Good morning, good morning. Welcome to a new series of sorcery devlogs. As announced before in my YouTube channel, I'm going to yeah, dig deeper in systems programming, and I'm going to try CodeCrafters DNS challenge. This time I've started this challenge last week. I did a few steps to see how much of a challenge it is for me. It was a lot of a challenge, to be honest. The main reason being I got used to use external libraries and build my applications on top of the abstractions the high-level languages provide. So this mindset of uh, processing bit and bytes was uh, kind of new to me. I understand how they work, but my brain doesn't start with solving the problem uh, that way, right? I always first look at what is the best way to do this thing, right? And how should I do this thing in my language, right? How you read this stuff. And then when it comes to Zig, it's um, not the usual way I do this stuff. So I thought it's a good idea to also do it on devlog because I again found myself procrastinating on it, and uh, uh, yeah, it wasn't as effective as I liked. So I thought, okay, I started Zig. It was the first series was quite promising. Let's again use the same structure and uh, dig deeper in the challenges of learning Z. And low-level programming in general, right? What I like about Zig is it's not uh, making assumptions about how I'm going to program. So I assume a lot of knowledge that I gain here because of uh, less abstractions given. A lot of knowledge I gain here is transferable to other languages as well. I'm mainly interested in C and C++. The main reasons being the focus on the embedded programming that I foresee in future that I'm going to do. But yeah, let's start the journey. It happens a lot that I don't know stuff, so I'm going to consult other solutions by other users in the community of CodeCrafters. I'm also having where is it? Yeah, over here. Copilot, I have an LLM open. Sometimes they suggest good enough solutions for me to dig deeper or help me to describe things and understand them, which is useful. And yeah, the screen structure, I kept it simpler this time, but you probably see me switching between them quite often. The main view would be my editor and my terminal. And yeah, I think I'll figure it out. Uh, let's see how it goes. So yeah, I'm going to repeat the setup here and take it from there. So yeah, introduction, I'm going to do the DNS server. Welcome to build your own DNS server. DNS is a protocol to resolve domain names to IP addresses. In this challenge, you'll build a DNS server that's capable of responding to basic DNS queries. Along the way, you'll learn about the DNS protocol, DNS packet format, DNS record types, UDP servers, and more. Preferred languages, yeah, I'm going to pick up Zig. Should I pick, yeah, a beginner, let's say. I know some concepts, at least after doing Ziglings, I hope that I know some concepts. And then, yeah, practice cadence, hopefully every day. Accountability, I'll pass. I don't want you to spam me. Be next step. What I need, basically copy. And then listening for git push, git commit, allow empty, rerun tests. Yeah, and git push. Okay, it's passed over here. Log and formatting, yeah. Looks like your program has terminated. The DNS server is expected to be long running. Okay. So how to pass this stage? Since this is the first stage, we've included some commented code to help you get started. To pass this stage, simply uncomment the code and submit your changes. Yeah. Okay. Mark as complete. And then we have the commented out code. We are going to uncomment and hopefully pass the test. But I would like to also do my dev and setup here, so I can run the code as well. Another thing that I just remembered. No, I don't want it to delete anything. Just go to CodeCrafters. Another thing I just remembered is Zig version. Oh, they updated the Zig version. The previous time I tried it, it was Zig 14. That's awesome. Then I can just go from calculator, pick up Nix and YAML, copy them here. while it's installing, I'm going to also use CodeCrafters CLI, but for some reason, yeah, basically I couldn't use this because of the configuration I have. I have this Git configuration that for specific directories I'm using different profiles. So for work I have a separate directory, and there it's using different GPG keys to sign and stuff like that. And then for sorcery I have its own keys. And then when I was trying to basically use this CodeCrafters CLI, I realized that it's not working. It's trying to sign it with my generic key, which was something I didn't want. So I debugged it a little bit and filed in this issue for them. Basically, what they are doing every time that you run the command, it will create a temp directory in the /temp on the system, and basically copy everything there and try to commit from there, and consequently you lose all the context of the Git configuration related to your current directory. I understand why they are doing it, but the best solution that I could find to resolve my own issue was to yeah, basically change the code to create the when it's going to copy the repository, create the temp directory inside the code.codecrafters subdirectory. And this way I could keep the context of the of my Git configuration, so consequently it was working the way I wanted it to work, using the right keys and stuff like that. So I submitted this PR. It has not been reviewed yet. Hopefully I get some feedback, because I'm not sure if it's the best way. This temp directory is kind of sometimes it's not going to get removed, so it might cause problems. I'm waiting for feedback to see what they think about it. But in the meantime, I'm going to use my version of the CodeCrafters CLI. Hopefully it works. Yeah, it's still compiling. Hopefully I have the correct configuration here, installing the Zig version 15. In the meantime, I think maybe we can start reviewing the code. Yeah, this is the piece that I need to uncomment, and hopefully it moves us to the next stage. But quickly checking what's happening, we are opening a file descriptor using POSIX socket method. I don't have the LSB yet, so I cannot read its documentation over here, but maybe Zig POSIX socket. Okay, this is a UDP socket. No, this is not documentation. Zig documentation, master standard library, yeah. And then POSIX is part of be std, yeah. POSIX dot socket. Yeah, this is the one. Yeah, probably open the src. This is better. No, that's not what I'm looking for. Is there a function like this? Socket, yes. There is not much documentation around it. These flags are not actually used, so if native OS is Windows, do something. Otherwise, have socket flags. Is Darwin, and it's not haiku. Okay, it's not Darwin, so it shouldn't be the Mac OS. And it's also not haiku. Okay, and then yeah, I think it's opening a UDP socket. At least that's what we need here. The first time I didn't read through the code, so I'm not sure about it. Okay, good. This one is also installed. Yeah, I have Zig version 15 and GLS version 15 as well. So let's load it here and load the LSP server as well. Nice. And then we are deferring to close this socket. Reuse, since the tester restarts your program quite often, setting so reuse address ensures that we don't run into address already in users. Okay. What we try here is to set socket options on this socket descriptor level socket upname reuse address, and then okay, we are setting the reuse function, and then we are assigning an IP version 4 to it. Oh, actually, it's not related to the socket. This is a different one. And then here we bind them together. Okay. We get an IP version 4 address and then bind the socket and the IP together. I'm still not sure how the process works, but I assume this is the required process. So you open a socket, and then you set option to it, and then you create an IP address, and then bind the socket and the IP address together. The first time I see this bit, I really liked it. How using an array of U8, they are representing the IP address before. So yeah, you can print this. You can use print the statement as follows for debugging. They'll be visible when running the tests. That's good. And then down here, I have a buffer of 1024 U8 unsigned bytes, which is undefined. And then we have infinite loop. We have client address undefined, client address length, size of POSIX socket address. Okay. POSIX socket address is a switch statement. Oh, based on the operating system, they are different. Okay. And then receive from this reads bytes inputs basically. We are throwing away the result, but it's taking a file descriptor where to read from and somewhere to put the result in. Flags, I'm not sure what is the meaning of it, and then client address and other slangs. Let's see if we have some description for this. If d is open non-blocking mode, the function will return. That's fine, but flags, what do they mean? Seems like we are just passing them down. And here we have a system. What is this system thing? Okay, I cannot find this. Okay, this is the realm where you need to either trust the examples you find or go down to the definitions of the code, because there is no documentation around it. But let's see if LLM can shed some light on it. So co-pilot in the following POSIX that directly from what is the use of flag. The flags parameter in direct view from controls the behavior of the receive operation. Common flags: message pick at incoming data without removing it from the queue. Wait for the full request or error. Non-blocking operation, return immediately if no data. Return real packet lengths even if larger than buffer. Receive out of one. You can combine flags using bitwise OR. Pass 0 for the default blocking behavior that consumes the received data. This is okay. This was quite crucial on the behavior. However, I'm not sure how they affect eventually, so I need to see them in action to make sure what some of these mean. So removing from queue, what happens if it's getting removed from the queue and stuff like that. Also, I assume when we have 0, all other flags also either have a static definition, something like an enum, or I have a value, but I can do an OR on top of it. It's like kind of how flags work in Python as well. Okay, this is good. Go to main.xig. And then we prepare a response. The response is empty and then send to. Cool. Let's close this. And then I commit. This is the first stage. Okay, let's do it here. The core, I don't want to see it in Git. Last time it committed like 20 megabytes and CodeCrafters wasn't accepting it. And then here, yes. Stage 1. And then what else I can do? Yeah, submit like this. I'm also taking some notes. I might release these notes every time I do a string on my blog as well. I said a string. I do a stream on my blog as well. I'm not sure why I said string. Anyways, and then yeah, this one passed. Let's go to complete this. Yeah. View next stage. In this stage, you'll implement your own solution. Unlike stage 1, your repository doesn't contain commented code to pass this stage. 98% of users who attempted this stage completed. Implement the solution, head over your editor and implement the solution. That's fine. Mark is complete. And then run the tests. Yeah, these we know. All communications in DNS protocol are carried in a single format called the message. Each message consists of 5 sections: header, question, answer, authority, and an additional space. In this stage, we'll focus on the header section. We'll look at the other sections in later stages. The header section of a DNS message contains the following fields. We've also included the values that the tester expects. Okay, we have ID, QR, opcode, AATC. Yep. Okay. The header section is always 12 bytes long. Integers are encoded in Big Indian format. You can read more about the full DNS packet format in Wikipedia or in IRC. This link is a good tutorial that walks through DNS packet format in detail. I will take a look at that. And then from the community, tool helper command. Okay, this is interesting. Do I have? Don't have it, I think so. Next, and then I also don't have Dig, I believe. Let's install those. In the meantime, let's take a look at this. tutorial. Chapter 1, the DNS protocol. It is in Go. Okay. I might read it, but let's put it in my reader for future to get back to this. And it's a very long RFC as well. Okay, but for now, let's continue with the problem at hand. I'm not sure how much detail I need to know about it. I'm not going to implement a fully fledged DNS server, so I don't have much interest to learn the protocol fully end-to-end, apart from what is required for this exercise, at least yet, right? In future, I might be interested to do some kind of project on it or expand the current implementation. So then I would like to read that, and I don't like to read it on a stream, of course. So. Okay, so there is this section, just like in previous section. The tester will execute your program like this. It will then send a UDP packet containing a DNS query to port 2053. Your program will need to respond with a DNS reply packet that contains the header information described above. We recommend creating an internal structure for DNS message in your code, as we will build on this later in later stages. Yeah, the tester sends an extra packet at the start of testing each stage. You can ignore it. Okay. Let's run the program first. What does this do? Your program. Oh, just do zig build and then run the main. Nice. And then there was some example. I doubt dig version would fully work here, so I'm going to try it with this. The dig version probably needs the whole packet to be ready, or it will send weird messages out. So, so we have some default values. We want the first 16 bits, 2 bytes, to be 1, 2, 3, 4, and the rest 1, 0, 0, 0. The rest is 0. And we have 12 bytes. So here I'm going to change this to 12, and then actually probably easier to do it like this. Right, and then the still compile. Maybe it's better to do zig build watch. Okay, yes. I want to put 12 bytes here, but they said it's big Indian. X. So in hex 1, 2, 3, 4 would be like this: 04D2, 0x04, 0xD2, and then 01, probably 1, and then 9 zeros, 4, 5, 6, 7, 8, 9. Let's open another one, and then the CodeCrafters DNS. Yeah, and then run the program down here. What happened? Was it fading? Oh, it's fading already. Oh yes, this here. Array literal requires address of, yes. And then let's exit, and now echo. Zero 04 D201. I hope this is what we supposed to do, but let's test it first. Expected QR field to be set to 1. One indicates that there's a response. QR, which bit is QR? Hmm. Uh, 0x10, maybe it should be like this. You're saying QR byte. Okay. Yeah, this is 2 byte hex. First byte, 11.1, maybe. Hmm. QR is 1 bit. Then if it's a 1 bit, shouldn't it work just like this? Let's ask LLM. I'm using Cloud, by the way. Copilot. In the following DNS Server response, I need the QR need to be set to 1. If it's 0, can you help me debug? Sick. The most significant bit of the QR bit is the most significant bit of the flags field in your response. Byte 2 is 1, which in binary is, I thought that's what I want. Okay, the QR bit oh yeah, even with, okay, now I get it. Python again, hex of 1, but it says the most significant 10 that I sent was an A. When it says 81, to set the QR bit to 1, change this sets the binary to okay for the first byte we are setting the most significant byte to 1. Okay. I'll go here 0x81. So the most significant byte. But I think then this should be less zeros, right? 2, 3, 4, 5, 6. No, it's the same amount. Oh yeah, each 0 is representing a U8, so this is also U8. So that's correct. And then we are setting the most significant byte, which means then, yeah, that's correct, because these are combined together, representing one value. So 1, 5, 6, 7, 8, 9, 12. Up until here, any value we want to add will be represented by this value. That's why I messed up. Okay, now if I do this and not you, echo this, I'm getting what I am sending, and then yeah. Okay, tests passed. No, I want to refactor the code. I thought a lot there. Can you please? I'm done. No, can you please show it to me? How can I? Show instruction again. Yeah. I want to see how others are doing it. Yeah, this is my previous submission and I didn't remember it again. Yeah. So they have an struct. They have an initializer for it to set these two values. And then they have a 2-byte method. Okay, this part I'm going to copy from them, and I don't want to for myself writing it. Const header struct. So we have their sizes here now. And then I can use it as is, but it's still, I have this problem that I need to do this myself. And I'm not very good at that. So what I can do, just like them, was add a function with the 2 bytes here. Input. Do I need an input? Let's say no. But what I'm going to return is an array of length to 8. Yeah, like this. And then I have var result 12 u8 undefined return results. Yeah. stdmem write int. Come time type u16 result first 2 byte value. Okay, it should be self dot id and then here like this. I think this is what we need. And then self and this. They build watch. It's compiling. I'm not sure if it's compiling because it's actually compiling or just yeah, ignoring this piece because it's not in use. I now need a few more. It's a U1 for UR. How does it work here? Oh, that. Wait a minute. I think here we can also do this. Let's comment this out for a minute. No. I want this. Yeah, exactly. So now I get what Claude meant by most significant bit. The most significant bit of this byte, these 2 bytes. Basically, actually, this part was necessary. It put an extra 1 there because I was setting it to 1. But it wasn't necessary, so the X80 would work, and that's also, yeah, in my previous answer. Cool. What I need to sneak peek is how they are doing this part. Yeah, so doing bit shifts to move the bit to the most significant bit of a byte. So then how? Oh, we are directly setting them. Okay, so result 2 equal to and then we are ORing them together. So as U8 self dot QR, move it 7 bits to the left, so it will be the most significant bit. As U8 U8 self dot opcode, move it 3 to the left, as U8 well AA, move it to the left. Okay, did I make a mistake? Might be. Let's finish. U8 self.tc. One to the left. And as U8 self.rd as is. How many bits I have? 1, 2, 4, 7, 8. That's one U8. And then I have result 3, which is as U8 self.ra seven as U8 self.z4 our code as is. And then for this one, go pick this, come down here. It will be 4 to 6 for UD count. D6, not you. 8, 10, 12, and 8. And here we will have in count, tennis count, AR count. I hope this is all correct. And now for the result, I can do the response would be header ID equal to 1, 2, 3, 4. I don't have the order, so what I do, like this, go up, QR equal to 1, up dot opcode 0 a 0 dot tc 0 dot rd 0 dot ra 0 0 UB count 0 0 DNS count 0 and the AR count 0. And yes, this is better. So the trick is, if you put one last comma, it will format it vertically, and if you remove it, it will be horizontally. And for long items, I prefer to have them vertically. And here the response would be 2 bytes, like this. Let's test our program. It's not compiling. Still need to pass it like this. Nice, and I'm getting an identical response. But let's add in it. What I would like to do is to extract this out to a file. What do they call it? It's part of a message. Probably I'm going to have a few more of these. Should I capitalize it? Let's not do it yet, but for this I'm going to capitalize. One nice thing that I learned in Zig, just like Python, when you do this stuff, you don't need to wrap them in an actual struct. You can do it like this. And then for convenience, I'm going to define a header of type this. Go here, remove this, put a header here. And also I need to import std and go to here, import header as message header.zig. Yes, it still compiles, hopefully. Okay, yes, that should be a public method. Indeed. Okay, they still have the same response. The reason I did this is I want to have first test. Basically test the same thing. Test header 2 bytes That's ID and QR. Let's say like this. And then I would like to have a convenience method. Pub fn from array. Then I would have an input of 12 U8 array, which returns a header. Right, and then here I'm going to have return header dot id equal to input 0 to 2 dot qr input How can I read that bit? How can I read this bit? This is interesting. Here I was able to put them into the most significant bit, but let's ask Claude. This is interesting. XP Copilot, please. How can I read the most significant bit of U8 input and assign it a variable? Really interesting. So if you want to read it, you use arrows on them. Okay, then here it would be like this 3 and then like this, and then opcode input 3. I'm not sure if it's correct, but let's move on and we will figure out. AA inputs. What I'm doing is basically reversing whatever I've done for writing it. PC input 3 one RD. No, this is not definitely correct. But let's move on and then we will figure out what's wrong with it. And RD I have. Let's ask it. What if I want to have bits between 3 and 7? Yes. To mask and shift. Was there any description on how to figure out the mask here? It was a mask. Elaborate on how to calculate the mask value. Calculate the mask for extracting specific bits you need to create. So you want to keep a 0 elsewhere. Okay, so here, and for mask, we are okay. Over here, I want between this I don't want. This 4 I want. These 3 I don't want. How could I think it's 0B, right? Yes. That's why 0x78. Was it what it said? I don't know what it's saying. F8. I do it like this for now. 78. But also shifting, right? So and 0x78. The rest is 1 byte. 4, 4. I want this. Yeah. 4 and 2. Okay. And okay, I messed up here. This shouldn't be inside the square brackets. It's like this. I just hate when my autocompletion messes up everything. Hopefully this is what I need. Then RA is again input for the most significant, and dot Z input 4 U3 U3 means okay. For Z we need to pick up from here 0x70 4, and for our code it would be input 4 and the first 4 are 0x08 0xf. Okay. And then for QD count we have input 5 7 should be 4 to 6. Did I mess up somewhere? This should have been 2 unzo replace T to 2, not you. Unzo query replace, yes, no. And then unzo 4 2 3, yes. And then here 4 to 6. Qt count, A and count, input 6 to 8. NS count, input 8 to 10. Dot AR count, input 10 to 12. Let's double check. verify this. There are several issues in your code. Beautiful type mismatch. Okay. Should be a cd read int. The main reason is no, I don't want to read it. Operator precedence is okay. I don't want to read it. I want to allocate and then use to byte for it. Maybe I could use to read it. But now, for now, I'm going to use this design. Operator precedence makes sense. Yeah. Okay, then the values are correct, however. That's fine. And then here, this is fine. This is fine. Okay. Now let's test it here. Down here, I want to say input is equal to up 12 u8, and then can I do 1 2 3 4 0? Actually, this is 5 6 7 8 9 10. And then header is equal to header for an array put input here and expect cd testing expect. Actually, probably better to just bring in testing. And then do testing expect. I hope this works. And then I have an expected. And actual would be header dot 2 bytes, right? And then expected is equal to a 12 byte array 0x. What was it? Drag off. Yeah, 0x4 0x e2 0x80 and 2, 3, 4, 5, 6, 7, 8, 9, like this. And then let's see, zig test src message header, it will fail. Yes. I want it to be 1, 2, 3, 4. Yeah, but he is right. Let's see how can I solve this. What's going on here? The error occurs because you can only this is exactly what I don't want to do. Int cast. Yeah, it's true. 1, 2, 3, 4 is a U16. Zero X. Then what's the benefit of it? For this from array, I want to maybe increase the size of array. Maybe instead of U8, use U16. No, then it would be a mess. Basically what I'm doing is what would be a nice way of passing value to it? Actually, I'm reading it in bytes here. Maybe it's not a bad idea to do 0x0d2. I think this is what I'm actually doing already. Unexpected U16 found. What is this suggesting? This is not what I want. This is what I want indeed. That also is not working because did I cast it? Okay, for now, what I'm going to do is forget about this. Comment this out. Here, I'm going to go to main.zig, copy this, and then put it here. Call this input. Forget this. Yes, it's going to be like this. Okay, this is passing. So we have a 2 bytes method that works, but I couldn't have a from array. This is something I'm going to get back to and fix. This is a convenient method, right? It would help me to not every time pass in all value names and just maybe use an array. But this opened an interesting challenge for me. I still, I think, need some more training to learn about bit manipulation. So I'm going to finish this stream here and get back to this in the evening, which I'm planning to have another session for this. And in the meantime, I might also invest some time learning about it, how we can do this. Thank you for your time. Feel free to leave a comment and let me know what do you think about my progress so far. I'm going to also share some of these learnings as a blog post in my blog, sorcery.zone. Thanks for your time. Have a nice day.